Hi, my name is Joe Pardue, known on the internet as Smiley of Smiley Micros. I'm the author of Smiley's Workshop and Nuts and Bolts magazine and several books. In this video tutorial, Simple Chaser Lights Kit Assembly Part 1, I'll show you how to build the Simple Chaser Lights kit that you can get from either Smiley Micros or Nuts and Bolts web store. This will continue in Part 2, and this is my first video, so there's some pretty obvious flaws in it. Just bear with me. We'll see how it goes.
Your Simple Chaser Lights kit will arrive in a plastic bag, something like this, and what you want to do before you start constructing it is dump all the parts out into a plate or something to keep them from falling off the table while you're doing the work. Let's first take a look at the bill of materials and the schematic, and then we'll come back and actually build this.
These are the parts from the Simple Chaser Lights kit. This illustration was in the March 2012 Nuts and Bolts magazine. As you can see, we have a table with all the parts named. The part number references the image, and we have the printed circuit board and socket. We have this pre-programmed Atmega 328. We have a 10K ohm resistor, we have a 100 nanofarad capacitor, and we have a 220 ohm resistor network, a 10K resistor network, and a 8 position dip switch. We have 8 5mm LEDs, and we have a battery box that holds 2 AA batteries. As I keep saying, you can purchase this kit from either Smiley Micros at SmileyMicros.com or Nuts and Bolts magazine. They have a web store also. This is a schematic for the Simple Chaser Lights board. As you can see, we have an Atmega. In our case, we have a 328, even though the part is labeled 8. They have the same pinout. This is the dip switch, which is connected up here to a resistor network. This resistor network is 10K ohm resistors, and they pull the switch up to, each switch is pulled up to 10K. When the switch is thrown, it connects the port to ground. So the port, when the switch is open, is pulled up to 5 volts through 10K, and when you close the switch, it is pulled down to ground to 0. Each of these LEDs here, like LED 0, is attached up here on one of the pins. LED 0 is attached to pin 27, and each LED is also attached to a resistor network. The resistor network in this case is 220 ohms, which provides enough current at our voltage, which is two AA batteries. So that's what about we see over here. This is a power connector where we have our VCC and ground pins, as you'll see in a moment on the printed circuit board. We have a 100 nanofarad capacitor attached between the AVCC and the ground and all that. And we have a 10K pull-up resistor here. Just for reference, I'll show you the board. Okay, and so you see the LEDs. This will make more sense when I show the actual printed circuit board during the assembly instructions.
Okay, in order to build this, you're going to need a soldering iron. Really, any soldering iron will do on something this simple. You know, a $5 Radio Shack soldering iron should work just fine. I use rosin core solder that you know, has the flux in the middle of the wire, and I've used this for years with no problems. All right, I've already installed 2 of the LEDs, but let's make a special point here of noting that the LED has a pad that's got a circle with a flat spot on it. That flat spot is mirrored on the LED itself and indicates the ground leg or the cathode leg. The ground leg is the short leg. Can you see this? Yes, the short leg. The short leg goes in this side over here. So you place that in there like that, and you put it down, and you just flip this over, and you tack your solder. Again, there's a lot of good references on the internet on how to solder. But first, I always put the one leg in, and then I look at it and make sure that it's flat and square. Let's go ahead and put all of these on now. Boom, put it boom. Put it down. Long leg in here, short leg in here, and we'll flip them over. As you can see, they're kind of held in position, but we're only going to do one leg at a time, and then we're going to make sure that they're pushed down properly. Okay, now let's check them. No, look, see, that's not all the way down. So I'm going to reheat the solder and push it down in position, and then check it. Nope, still not down. Ugh. Pull it up. Check this flat. I'm not checking, am I? Pull it up. Now they're all on there flat. They look flat to me. Okay, now I'll solder the other side. Okay, and the last one. All right. Now, you'll need some flush cutters. No. You need flush cutters, and you need to keep in mind, when you cut this thing off flush, these legs will go rocketing off, and they can blind you. One of these things could stick in your cornea when it comes off, and bingo. Well, that one didn't go rocketing off. Who knows, maybe none of them will, but sometimes they will go twing, so you should wear safety glasses. Okay, a mess. Let's get those out of there. All right, let's see. The next thing I want to solder on here is the 10K ohm resistor. Your 10K ohm resistor, let's hold it up here. You see it's got a couple of long leads. You just bend them like that. Bend them down. This thing is not polarized. Doesn't matter which way you put it in. Just make sure you get it in the one that says 10K, like this. And just pull it down. Get a good approximation of centering it. Then pull the legs out so that you can solder it on. Sorry about that. This pad's not being perfect, but they'll do. Now, we'll put the capacitor on next. And the capacitor also, you'll notice that the legs aren't exactly the right. Okay, so you notice the capacitor's legs aren't the proper width either, so we'll pull that out a little bit. We'll put those in, and we'll try to keep it centered when we push it down. Keep it centered when you push it down. Oh, I'm not even showing it here. Okay, keep it centered when you push it down. And like that, get it down, keep it centered. You know. And again, it's not perfectly sized for the pad, but it'll work just fine for what we're doing. Let's solder this on. Solder that on there. Solder that on there. And make sure our solders are decent. Then, again, safety glasses.